Well, the final lesson in this unit, areas of similar figures. These are the content standards and the mathematical practices with the lesson. There's no new vocabulary, but previously you've used scale factors and proportions to solve problems involving the perimeters of similar figures. Now you're going to find areas of similar figures by using scale factors. And you're going to find scale factors or missing measures given the areas of similar figures. Previously, you've learned that if two polygons are similar, then their perimeters are proportional to the scale factor between them. Now, the areas of two similar polygons share a different relationship, as shown in Theorem 11.1. If two polygons are similar, then their areas are proportional to the square of the scale factor between them. So if ABCD is similar to PQRS and the area of ABCD is 48 square inches, find the area of PQRS. So the scale factor 9 to 6 or 3/2, so the ratio of the areas is the quantity 3/2 squared. So the area of quadrilateral PQRS over the area of quadrilateral ABCD is equal to the square of the scale factor, which is 3/2. So write a proportion. You know what the area of ABCD is. So we take the square of that scale factor, multiply it by 48 to find the area of PQRS. So the area of PQRS is 108 square inches. Okay, check your progress on this one. Pause the video, work the problem, then come back and check your answer. Well, the scale factor, 12 to 4, 12 divided by 4 is 3. 3 squared is 9. 9 times 40 is 360 square feet. You can use the areas of similar figures to find the scale factor between them or a missing measure. Here we're given that the area of triangle ABC is 98 square inches. The area of triangle RTS is 50 square inches. If triangle ABC is similar to triangle RTS, find the scale factor from ABC to RTS and the value of x. So first of all, we don't know the scale factor, so let's let K represent the scale factor between these two triangles. And of course, if you remember, we have to square the scale factor. It's equal to the area of triangle ABC over the area of triangle RTS. We simplify 98 over 50 because, as you see, 2 goes into both of those numbers. Take the square root of both sides. So K is equal to 7/5. So the scale factor from ABC to RTS is 7 to 5. Now we're going to use the scale factor to find the value of x. 14 relates with 7, so 14 over x is equal to 7 over 5. Cross multiply and solve for x. So the value of x is 10. You can confirm that CB to ST is equal to the scale factor. Since you got 10 for ST, is 14 over 10 actually 7/5, and yes it is. So that one checks. Now it's time for you to check your progress. So pause the video, work the problem, then come back and check your answer. All right, so we're going TUV to NOP. So I went 72 over 32 is equal to K squared. The value I get for K is 9 over 4. 9 is to 4 as 9 is to x. Cross products, multiply, solve for x. X is equal to 4. And right, if the scale factor we get was 9 to 4, then x has to be 4. Earlier you learned that if all corresponding angles are congruent, and all corresponding sides are proportional, then two polygons are similar. For this reason, all regular polygons with the same number of sides are similar. So looking at a scale model, we've got the area of a skyscraper is 90,000 square feet. The area of one side of a scale model is 200 square inches. Notice we've got two different units here. If the skyscraper is 720 feet tall, how tall is the model? So since we're going to be trying to find in feet, let's change our square inches to feet. So 200 square inches is 1 and 389 10,000 square feet. Now let's write an equation using the ratio of the two areas of square feet. We're going to let K represent the scale factor between the two sides. So we've got the area of the model to the area of the skyscraper equals K squared. Simplify using a calculator and take in the square root. So the model's height is 39 over 10,000, the height of the skyscraper. So now we're going to multiply the height of the skyscraper by the scale factor and convert to inches. So the scale model is about 34 inches tall. We can check by multiplying back. Notice this, we have to take the square of the scale factor when we do that check. All right, time for you to check your progress. So pause the video, work the problem, then come back and check your answer. 5 8/10 inches. Again, we change the square inches to feet. And then K is equal to 43 over 1250. Multiply that by 14 and then by 12, and we get 5 8/10 inches. Very good. You're ready to begin the assignment.